The second question of Objective 8, again dealing with excess and limiting reagents. Calcium carbonate reacts with phosphoric acid, and it produces calcium phosphate, carbon dioxide, and water. Turning that into a balanced equation, beginning with the first calcium carbonate reactant. Calcium, Ca, carries a positive 2 charge. Carbonate polyatomic ion, CO3, carries a -2 charge. CaCO3, our formula for calcium carbonate. Then it says reacts with. We know that to be the plus sign. It's reacting with phosphoric acid. Ic comes from 8. We look up phosphate, polyatomic ion. Knowing that acids start with hydrogen, that it's a +1 charge. The polyatomic ion phosphate carries a -3 charge. Our formula for this acid, H3PO4. The next words read, to produce. We know that to be the yield sign. It produces calcium phosphate. Calcium +2. That polyatomic ion phosphate is a -3. Ca3PO4 taken twice. Then we see a comma, carbon dioxide. We'll separate our products with a plus sign. Carbon dioxide written as CO2. And the third product is water, H2O. Our skeleton, CaCO3 plus H3PO4 yields calcium phosphate, Ca3 parenthesis, PO4 taken twice, with carbon dioxide and water. We will now work to balance our equation. I notice that there's 3 calciums on the product side. This might be a good place to start with a 3 in front of the first reactant, balancing the CAs. Then I notice that also gives me 3 calcium, or 3 carbons, 3 units of Cs. I notice over here I have just 1 carbon. I predict a 3 in front of the carbon dioxide. Here I'm noticing 2 units of the polyatomic ion phosphate. 2 units of the parenthesed PO4 tells me I should double the acid, giving me 2 units of the PO4 polyatomic ion on both sides. This also gives me 6 hydrogens. 2 times 3 is 6. I predict a 3 in front of the water. 3 times 2 is the 6 H's I see left to right. 3 carbons, 3 calciums, 3 calciums, 3 carbons, 6 H's, 2 units of PO4 were balanced. 3 to 2 to 1 to 3 to 3 balances that equation. Letter B. How many molecules of carbon dioxide form when 50 grams of calcium carbonate react with 70 grams of phosphoric acid? How many molecules of CO2? My want is the number of molecules of CO2. I'm given 50 grams of the first reactant, CaCO3, and 70 grams of the second reactant, H3PO4. We will work 2 separate stoichiometry problems deciding the maximum yield. Let's begin. We'll write 50 grams of CaCO3, getting our 3 parentheses ready. Divide, ratio, multiply, where we want the molecules of CO2. We will now set up our second journey. Given 70 grams of H3PO4, divide, ratio, multiply, where we have the same want, the molecules of CO2. We want the number of molecules given the mass of both reactants. We'll work the first problem, knowing in that first parenthesis I'll need a molar mass of calcium carbonate. Calcium has a weight of 40, plus 12 on the carbon, plus 16 times 3 on the oxygen. That gives me a molar mass of 100 grams for CaCO3. We move to the heart of the problem, our want over given. We want the CO2, its coefficient of 3 gets placed on the top. From the calcium carbonate, its coefficient of 3 gets placed on the bottom. To bring it out to the number of molecules, we need to use Avogadro. There is exactly 6.02 times 10 to the 23rd molecules of CO2 in any 1 mole of CO2. I will hit 50 divided by 100. 3 over 3 simply cancels, times 6.02 E23. And my screen is reading 3.01 times 10 to the 23rd molecules of CO2. If the second reactant is indeed giving us the maximum yield, it will produce a smaller of the two numbers, or perhaps it will work out larger, showing that it's in excess amounts. Let's work the second problem so we can then compare the two answers. In our first conversion, 1 mole of H3PO4 set over its molar mass. Hydrogen, there's 3 of those, so that will be 3 plus 31 on the phosphorus, and 16 times 4 for the oxygen gives me a molar mass of 98 grams for H3PO4. In the heart of the problem, we want the carbon dioxide. Its coefficient of 3 gets placed on the top. Given the number of moles of phosphoric acid, its coefficient of 2 gets placed on the bottom. 3/2 is our ratio. Again, the same target is molecules. We place Avogadro on the top for every 1 mole on the bottom. Hitting for this, we would hit 70 divided by 98 times 3 over 2 times 6.02 E23. And when I hit, I find 6.45 times 10 to the 23rd power. The maximum yield is the smaller of our two numbers. They have the same magnitude on the times 10. They're both raised to the 23rd power. So I consider only the beginning numbers. 3 is a smaller number than 6. So my maximum yield is 3.01 times 10 to the 23rd power molecules of CO2. The smaller of our two answers is the maximum yield.